Okay, this is going to be the law of sines, and this is a triangle. And notice it's not a right angle triangle. So what we want to do is, we're going to turn it into a couple of right angle triangles because you can't really do trig unless you have right angle triangles. Well, sort of. And we're going to learn all about that today. Okay, so I'm going to call this angle A. So the opposite side, that's the side that if you wander away from angle A, it's the first side you're going to smack into. Okay, and that's side A. And so I'm going to call this angle B. So the first side we smack into is going to be side B. And that's angle C. So the first side we smack into is going to be side C. All right, and I'm going to turn this into a couple of right angle triangles by putting a height right there. And I'm going to label that H. Okay, so now if we look at the sine of A, we know the sine of A is the opposite over the hypotenuse. So the opposite of A is H, and the hypotenuse is going to be C in this right angle triangle. Okay, so we're going to have the sine of A is H over C, and that's about it. Now I'm going to do one step, and I'm going to explain that step in a couple of minutes. Right now I'm just going to get the H alone by cross multiplying the C. So I'm going to get C times sine of A is equal to H. I'll explain in a second why I got the H alone. Okay, if we look over here at this right angle triangle, okay, we have C is equal to, or the sine of C is equal to the opposite over the hypotenuse, so H over A. So sine of C is H over A, and if I cross multiply the A, I get A sine of C is equal to H. Now in both cases, I've isolated the H in both cases, so that means that, and this is why I isolated the H's. So C sine of A must be equal to A sine of C, which is really neat. Okay, so C sine of A is equal to A sine of C, and if I cross multiply the A, cross multiply the C, or divide both sides by C, divide both sides by A, whichever way, we end up getting sine of A over side A is equal to the sine of C over side C. Okay, and that is a very big part of the law of sines. Now if I just take this triangle and I rotate it a little bit, okay, so the A is now here, the B has come down, it's now here, and that C is rotated up and it's up there. Okay, so this is side C down here. This is angle B, so that's side B. This is angle A, and that's side A. All right, and if I make my new height, now this is a different height, I'm just going to call it H2. Doesn't really matter that it's H2, but that's just another height. And so what I'm going to say is the sine of B is going to be the opposite over hypotenuse, which is going to be H2 over A. Okay, and then if I want to get the H2 alone, so I'm going to cross multiply the A. I get A times sine of B is equal to H2. Okay, so this part doesn't make sense right away, but it will. And over here, if we look at the sine of A, we're going to have the opposite over hypotenuse, so H2 over B. So sine of A is H2 over B. Cross multiply the B, we get B sine of A is equal to H2. Okay, the reason we isolated the H2s again is so that we can say A sine of B, which is equal to H2, and we have B sine of A, which is equal to H2. So A sine of B must be equal to B sine of A. These things are the same thing. So we're going to write them as the same thing. So B sine of A is equal to A sine of B. I'm going to cross multiply my lowercase a, or the side A. I'm going to cross multiply the lowercase b, or the side B, and I'm going to get sine of A over A is equal to B over sine of B over side B. Okay, very similar to what we have up here. Okay, in fact, sine of A over A, sine of A over A. Okay, up here it's equal to C, sine C over side C. Here it's equal to sine of B over side B. Well, if both of these are true, then we can equate all three of them. We can say sine of A over A is equal to sine of B over side B is equal to sine of C over side C. And this is the law of sines. Have a good day.